Antarctica, 250 million years ago. Waterborne sand, silt and vegetation are deposited layer by layer. Today these layers are the rocks of the transantarctic mountains and are a record of the continent's history. Reading this record has been the work of many geological parties, mainly small like ours. The expedition was the 15th from Victoria University, working mainly in the mountains west of Scott Base, but near the end of the season, 4 of us extended the studies south. In a US Navy Hercules, 200 kilometers took us only 40 minutes. Then out with 2 tons of equipment, camping and geological gear, and a month's food. A week of local work, then the 40-kilometer journey to the previously unexplored Hatherton Glacier. One motor toboggan, the blue one, was a new snow trick, light and fast. The other was an old and tried Polaris. Trouble came as we turned into the Darwin Glacier, a small crevasse. Quite pleasant in the warm sun, but frustrating. Only 10 kilometers from camp after 3 hours. But things got worse. With steep slopes and icy patches, the next 30 kilometers took 9 hours. Still, we were better off than the Allen Hills party a few weeks previously. They moved camp by man-hauling their sled, like most of the early British parties. They told us of one good day, in which they covered 30 kilometers in 18 hours. We eventually arrived at the Hatherton Glacier about midnight and set up our camp for the next week. By 2 in the morning, camp was established and we could relax a bit. The mountains here are like those elsewhere in the transantarctic chain. The top 1,000 meters or so are flat-lying sedimentary strata of late Paleozoic and early Mesozoic age. Our aim was to measure and describe the rocks in detail, taking the best exposed outcrops we could reach. We hoped to find characteristic strata or fossils to use for correlating formations in this area with those to the north and south. We went mainly in pairs, working from bottom to top on mountain faces we'd previously picked from maps and air photos. One of us measured the thickness of each bed in steps, using a level mounted on top of a staff 1.5 meters long. The other wrote down the rock description. Rock type, color, grain size, bedding features, and so on. From the description and measurements, we later compiled this diagram. There are 5 distinctive sedimentary formations in the area. The oldest is the junction sandstone, formed from coarse, river-deposited sand. But here at Mistown Cirque, it's under the ice. The exposed section begins with the Hatherton sandstone. From some of the samples, we later cut thin sections for microscope study. The two types of sandstone are clearly different. This is junction sandstone. The grains are poorly sorted, moderately rounded, mostly quartz but some feldspar, with about 10% clay. Here is Hatherton sandstone. Grains all about the same size, well-rounded, and entirely quartz. Other minerals like feldspar have been removed by millions of years of reworking and winnowing. The surface we're standing on is the top of the Hatherton sandstone. It was eroded in early Permian times by glaciers then covering the area. Granite boulders are scattered through the layer of debris left behind when the ice melted. Recent glacial striations are common enough, but these are the first ancient ones to be found in the Darwin Mountains. They show that the ice flow was in a northwest-southeast direction. As the glaciers retreated, rivers shifted and graded a lot of the glacial debris. This now forms the mist-hound coal measures, mostly sandstone, but a few thin coal beds. Note-taking is slow with gloves on, but you need them at -10 centigrade. More samples. We collected 200 altogether. A thin section of mist-hound sandstone is quite like the junction 500 meters below. Mostly quartz, with a little feldspar, but better sorted and finer grained. Most of it probably eroded from nearby granitic rocks, but some grains have had a long history. This round one came from the underlying Hatherton sandstone. There's only one coal bed here, 1.5 meters thick, in 150 meters of sandstone and shale. But beds of carbonaceous shale are common. These accumulated in swampy backwaters on the floodplain and are good places to find leaves and stems. Here's a stem impression. The leaves are more useful though, because they can give us the age of the beds more accurately. The Nergarathiopsis and Glossopteris leaves here indicate an early Permian age for the beds, and ripple marks show the stream flow direction at the time, to the southeast. Cross-bedding also indicates a southeasterly stream flow. It forms as the current moves the sand from the upstream to the downstream face of a migrating underwater dune. At this locality, the mist-hound coal measures are capped by massive cliffs of dolerite, intruded during the Jurassic period. The dolerites crystallize slowly from molten basalt and look quite distinctive under the microscope. Crystal faces are straight, angles constant, edges sharp. About 40% of the rock is plagioclase, and most of the rest is pyroxene. We didn't need to measure the thickness of the dolerite, but we usually climbed up to see the view. Most of the mountains here are flat-topped, because the dolerite is hard and resists erosion. The cliffs are 10 kilometers away and 1,000 meters high. More dolerite. A week gone and we'd studied the best outcrops. With 4 or 5 days geology to do on the way, it was time to move the 40 kilometers back to the landing site. We felt a bit nostalgic packing up. This isolated spot had been our home for a week. Leaving our campsite was not as easy as getting down to it. The climb up from the glacier was steep, and we had to relay our gear in 200-pound loads. Even the Polaris would not pull straight up the slope and had to zigzag. But then, trouble. A broken axle and no spares or tools for a major breakdown like this. The snow trick was showing signs of wear too. We relayed our gear and samples another 3 kilometers on to the only likely landing site in the area and radioed Scott Base. 2 days later, we were glad to hear the sound of Hercules. In half an hour, we were heading home, pleased with what we'd accomplished, but thinking regretfully of the work we had to leave. This time, anyway.